Good morning, everyone. Today we are going to explore a very important topic, STEM educational skills. STEM is not just about science, technology, engineering, and mathematics as separate subjects. It is really about the skills that learners build when these subjects are taught together in meaningful ways. These skills prepare students not only to understand content, but to think critically, solve problems creatively, and innovate responsibly. So, what exactly are these skills? In this session, we will focus on the four major STEM education skills: mathematics skills, science skills, technology skills, and engineering skills. Each has its own processes and approaches, but they connect and support one another. By the end, you'll see how these skills form the backbone of STEM education. Let's begin with mathematics skills. Mathematics skills are more than memorizing formulas or calculating numbers. They include the ability to use correct mathematical language, to reason logically, and to present ideas in a clear and concise way. Students also need to be able to test conjectures, solve word problems, and apply mathematics to explain the physical world around them. These skills build precision in thinking and clarity in communication. Mathematical skills are not just about numbers or formulas. They are a combination of different abilities that work together. At the center, we have mathematical skills, and around it are 5 connected skill areas. First, research skills, where learners gather information from books, notes, or digital sources to support their problem solving. Second, analyzing skills, which involve breaking down ideas, looking at details carefully, and constructing logical arguments. Third, problem-solving skills, the ability to identify issues, think of possible solutions, and approach problems with confidence and flexibility. Fourth, communication skills, which include listening, speaking, and writing clearly to express mathematical ideas and reasoning. And finally, information and communication technology skills, which mean using tools like calculators, computers, or software to explore, test, and prove mathematical ideas. Together, these areas create a complete picture of what it means to be skilled in mathematics. Each one strengthens the others, and all are essential for learners in STEM education. Analyzing skills are one of the core components of mathematical skills. They help learners move beyond simple calculations and into deeper reasoning. When we talk about analyzing in mathematics, we mean thinking clearly and paying close attention to detail in every aspect of a problem. It involves manipulating ideas precisely, concisely, and in detail, without losing focus on accuracy. Analyzing skills also mean being able to understand complex reasoning, construct logical arguments, and defend them with evidence. At the same time, students must learn to recognize and debate illogical arguments, which strengthens their critical thinking. In short, analyzing skills make mathematics more than just numbers. They make it a structured way of thinking that builds clarity, logic, and precision. Problem solving is at the heart of mathematics. It is the skill that allows learners to take a challenge, break it down, and work towards a solution with confidence. To solve problems effectively, students must first learn to construct problems precisely and identify the main issues. Once that is clear, they need to present solutions in a way that is logical, structured, and based on clear assumptions. Problem solving also involves tackling difficult tasks by analyzing smaller, simpler problems first. This step-by-step approach makes complex issues more manageable. Another key element is open-mindedness. Students should be willing to explore different approaches to the same problem, rather than sticking to just one method. This builds flexibility in thinking. Finally, problem solving requires confidence, even when the solution is not immediately obvious. And importantly, students should know when to ask for assistance, recognizing that collaboration and guidance are part of the learning process. In short, problem-solving skills empower learners to face mathematical challenges with clarity, creativity, and resilience. Research skills are an essential part of mathematical learning because they allow students to find, access, and use information effectively. When we talk about research in mathematics, we mean the ability to refer to notes, textbooks, and other reliable sources. Students should also know how to access books in the library and make use of digital databases to find accurate information. Research skills also include the ability to gain knowledge from various individuals, such as peers, teachers, or experts, and to integrate those perspectives into their own problem solving. And at the core of all research is the ability to think, to analyze, to question, and to connect the information they gather. In short, research skills help learners to become independent thinkers, able to support their mathematical reasoning with evidence and reliable sources. Communication is one of the most important mathematical skills because it connects ideas, people, and understanding. In mathematics, communication goes beyond just talking. It is the process of expressing ideas clearly and making sure they are understood by others. A good communicator in mathematics is someone who can both listen and speak effectively. Listening attentively is the first step because it shows respect for others' ideas and ensures that we understand the reasoning behind their thinking. Equally important is being able to write and express mathematical ideas precisely. This means using the correct mathematical language, symbols, and structures so that the meaning is clear and not misunderstood. Writing skills in mathematics also extend to producing essays and reports where students must explain their reasoning in an organized and logical way. This helps them to not only show the answer, but also the process that led to it. Another vital part of communication is presentation. Students need to be able to stand in front of others and present their mathematical ideas confidently, whether that is in small groups or in front of the whole class. This builds confidence, strengthens their understanding, and trains them to justify and defend their solutions. When communication skills are missing, even correct solutions may remain hidden or unclear. But when students learn to listen carefully, explain ideas with precision, write with clarity, and present confidently, their mathematical thinking becomes more powerful. In short, communication skills ensure that mathematics is not just correct, but also shared, understood, and valued by others. Information and communication technology skills are now an essential part of mathematics education. These skills focus on the ability to use and handle different mathematical tools, both traditional and digital. On the one hand, this might involve simple tools like the abacus or calculators. On the other, it includes modern devices such as computers, educational software, websites, and digital learning packages. When used effectively, ICT skills allow students to develop a deeper understanding of mathematical concepts. For example, using graphing software or dynamic geometry tools can help learners see patterns, test hypotheses, and visualize abstract ideas more clearly than through numbers alone. Another important function of ICT in mathematics is the ability to create, test, and prove conjectures. Instead of relying on trial and error with pen and paper, students can use software to test multiple scenarios quickly and identify whether their reasoning holds. This encourages curiosity and supports mathematical creativity. ICT skills also open up opportunities to explore mathematical ideas in a wider context. Students are no longer limited to textbook examples. They can use simulations, interactive platforms, or even coding to extend their learning. And of course, ICT tools are powerful for solving problems. Whether it is calculating complex data, modeling real-life scenarios, or collaborating through online platforms, technology gives students greater efficiency and flexibility. In short, ICT skills in mathematics go beyond simply using devices. They are about applying digital tools to deepen understanding, to test and explore, and to solve problems in innovative ways. By mastering these skills, students prepare themselves for both academic success and real-world applications of mathematics. Now that we have looked at the different mathematical skills, let us turn to the mathematical process. The process refers to the ways in which students acquire, apply, and connect mathematical knowledge. In other words, it is not only about what students know, but also about how they think, how they reason, and how they communicate their ideas. The mathematical process is made up of several connected elements. These include problem solving, reasoning and proving, reflecting, representing, connecting, and communicating. Each part works together to help students think mathematically in a clear, logical, and meaningful way. The mathematical process is really the heart of how students engage with mathematics. It is not only about knowing formulas or memorizing procedures, but about the way they acquire, apply, and connect mathematical knowledge, concepts, and skills in meaningful ways. In other words, the process is what transforms mathematics from a set of rules into a way of thinking and problem solving. When we talk about the mathematical process, we include a set of key elements such as problem solving, reasoning and proving, communication, reflection, connecting, and representing. Each of these processes plays a different role, but none of them stand alone. They are all linked and constantly reinforce one another. For example, when a student is solving a problem, they are not only applying procedures, but also reasoning about why those steps work. At the same time, they may reflect on whether their solution makes sense, communicate their reasoning to others, and use representations such as graphs, tables, or diagrams to make their ideas clear. The strength of the mathematical process is that it develops students into independent and confident thinkers. Instead of approaching mathematics as a rigid subject, they begin to see it as flexible and creative, with multiple pathways to a solution. This is why the process is so valuable. It gives learners the tools to think critically, connect ideas, and apply mathematics to real-world situations. Ultimately, the mathematical process is not just about doing mathematics in school, it is about learning how to think mathematically in life. Problem solving is at the very center of doing mathematics. It is not just an activity, but the foundation of mathematical learning. When students engage in problem solving, they are not simply applying procedures. They are exploring ideas, testing their reasoning, and connecting concepts. This makes problem solving one of the most powerful ways for learners to develop true mathematical understanding. The process of problem solving gives students opportunities to both use and create mathematical connections. For instance, when they face a challenge, they must think about what knowledge they already have, how different concepts link together, and what strategies might lead them to a solution. Through this, they build deeper conceptual understanding rather than just surface-level answers. Problem solving also ensures that mathematics remains student-centered. It acknowledges that every learner brings their own experiences, prior knowledge, and questions into the classroom. By placing students' experiences and queries at the heart of learning, mathematics becomes more meaningful, engaging, and relevant to their lives. In short, problem solving is more than an isolated skill. It is the basis of effective mathematics programs because it encourages creativity, critical thinking, and persistence. It transforms mathematics from a subject of rules to a subject of discovery and application. Problem solving in mathematics does much more than just help us find answers. It encourages reasoning, the ability to think through a problem carefully, test ideas, and reach either a solution or a new understanding. This makes problem solving a powerful tool for developing critical and creative thinking. It also promotes questioning. When students are problem solving, they naturally ask, "What do I know? What do I need to find out? What strategies might work here?" In doing so, they often make conjectures, predictions, or hypotheses about what might be true. They then justify their solutions with reasoning and evidence, strengthening both their mathematical thinking and their confidence. Another important feature of problem solving is that communication and reflection are not limited to the end of the task. They happen before, during, and after solving a problem. Beforehand, students share their strategies. During the process, they compare their progress and adjust their methods. Afterwards, they reflect on whether their solution was effective, whether another method could have worked, and what they have learned from the experience. So, why is this continuous cycle of communication and reflection so important? Because it ensures that mathematics is not treated as a one-step answer hunt, but as a journey of thinking, sharing, and improving. This is what makes problem solving such a rich and meaningful part of mathematics. Problem solving plays a vital role in helping students grow as mathematical thinkers. One of its greatest benefits is that it provides many opportunities for the use of critical thinking skills. When students solve problems, they select appropriate tools and strategies, estimate and evaluate their answers, classify information, make assumptions, recognize relationships, and even pose new questions. They also learn to offer opinions with reasons, make judgments, and test conjectures. All of these actions build strong mathematical reasoning and push learners to think at a deeper level. Problem solving also has an important personal impact. It helps students to develop a positive mathematics identity. When they successfully engage with challenges, they begin to see themselves as capable problem solvers. This builds confidence and motivation, reducing the fear that mathematics is only about getting the right answer. Another key point is that problem solving allows students to draw on their rich prior knowledge. Every learner brings something with them into the classroom: previous strategies, experiences, or insights. By encouraging students to use what they already know, we validate their background knowledge and connect it to new learning. So, problem solving is more than just a skill. It is a process that develops critical thinking, builds confidence, and connects students' past learning to new mathematical ideas. Problem solving is not only central to mathematics, it is also the bridge that connects mathematical knowledge to the real world. Through problem solving, students learn to make meaningful connections between concepts, skills, and everyday situations. This helps them see mathematics as something practical and useful, not just abstract ideas in a textbook. Another important benefit is that problem solving promotes collaborative learning. When students share their ideas and strategies, they learn from one another and discover that there is often more than one way to reach a solution. This exchange of thinking develops flexibility and strengthens communication skills. Problem solving also provides opportunities for creative thinking. Instead of following a fixed formula, students are encouraged to try new approaches, design alternative strategies, and test out different pathways. This makes mathematics more dynamic and open to exploration. Finally, problem solving helps students find genuine enjoyment in mathematics. As they gain confidence through solving challenges, they begin to believe in their own ability to do mathematics successfully. Problem solving in mathematics becomes more effective when students are equipped with a range of strategies. These strategies provide different entry points into a problem and help learners approach challenges with flexibility. One strategy is simulating, where students act out or model the situation to better understand it. Another is making a model, picture, or diagram, which allows them to visualize relationships and patterns. Students can also look for a pattern or use guessing and checking to test possible solutions and refine their approach. Organizing information is another powerful tool. Students may create a list, a table, or a chart to make sense of data and reveal structures that are not obvious at first. Similarly, they can solve a simpler version of the problem, such as using smaller numbers, before applying the same logic to the original question. Some strategies focus on reversing the problem. For example, working backwards can often provide clarity when the forward path seems too complex. Finally, using logical reasoning ensures that each step is supported by evidence and sound thinking. By learning and applying these strategies, students not only improve their ability to solve problems, but also become more confident, creative, and independent thinkers. The goal is not to rely on one fixed method, but to have a toolbox of strategies that can be applied in different situations. Reasoning and proving are at the core of doing mathematics. They involve using mathematical knowledge, concepts, and skills to justify thinking and ensure that solutions are not just correct, but also logically sound. In other words, it's not enough to simply find an answer. Students must be able to explain why that answer makes sense. This process is a key part of learning mathematics because it shifts the focus from rote procedures to deep understanding. When students reason mathematically, they develop the ability to see connections, identify patterns, and construct logical arguments that can be defended with evidence. There are different forms of mathematical reasoning that support this process. These include proportional reasoning, which helps students compare quantities; algebraic reasoning, which allows them to work with symbols and generalizations; and spatial reasoning, which involves visualizing shapes, spaces, and structures. Other important forms include logical reasoning, where students build step-by-step arguments, and probabilistic reasoning, which helps them understand uncertainty and chance. Together, these types of reasoning strengthen a learner's ability to prove solutions, justify ideas, and challenge incorrect arguments. By practicing reasoning and proving, students are not just learning mathematics. They are learning how to think critically, make sound judgments, and build confidence in their ability to explain and defend their ideas. Reasoning and proving are powerful parts of mathematics because they show us why an answer makes sense, not just what the answer is. Students apply reasoning by drawing on their knowledge of numbers, operations, geometry, and measurement to solve problems. This means they are not working in isolation. They are applying multiple areas of mathematics to justify their ideas. A key part of this process is forming conjectures. Conjectures are statements or predictions that students think might be true. By testing and proving these conjectures, they learn how to support their thinking with evidence. Over time, this helps them to move from relying on other people's justifications, like simply accepting a teacher's answer, to independently proving their own ideas and being confident in their reasoning. Of course, teachers play a vital role in this development. Our job is to create opportunities for students to make and test their own conjectures, instead of always giving them ready-made answers. We must also guide them to justify their solutions with logical evidence. By doing this, we help students build habits of critical thinking, independence, and resilience in their mathematical learning. So, reasoning and proving is not only about solving problems, it's about building a mindset. A mindset where students can confidently say, "This is my answer, and here is the evidence that proves it." That's the real strength of reasoning in mathematics. Reflection is an essential part of the mathematical process because it encourages students to think about their own thinking. During problem solving, reflection involves monitoring the thought process carefully, identifying what is working and what is not, and deciding whether the current approach is effective or if another strategy might be more successful. This builds awareness and flexibility in problem solving. After solving a problem, reflection continues. At this stage, students need to check the reasonableness of their answer. Does it make sense in the context of the problem? Is it logical compared to the information given? If something doesn't seem right, adjustments may be needed. This could mean reworking part of the solution, trying a different method, or refining their explanation. In short, reflecting ensures that students don't just rush to an answer and move on, but instead pause to evaluate and improve their work. This habit develops critical thinking, self-awareness, and the ability to learn from mistakes, all of which are essential for becoming confident and independent mathematical thinkers. Reflection does not happen automatically. Teachers play an important role in guiding students to reflect. One effective way is by asking questions that encourage students to examine their own thought processes. This is what we call metacognition, or thinking about one's own thinking. By pausing to ask, "Why did you choose this method? What worked well? What might you do differently next time?" Students start to become more aware of how they approach problems. Teachers can also encourage learners to consider other students' strategies. By comparing approaches, students learn that there are many ways to solve a problem, and they begin to appreciate the strengths and limitations of different methods. This broadens their perspective and deepens their understanding. The benefits of reflection are significant. It helps students build metacognitive skills, which are essential for lifelong learning. Reflection also strengthens connections between new knowledge and past or future problems, making mathematics more coherent and meaningful. In short, reflection transforms mathematics from a routine exercise into a thoughtful process. It ensures that students don't just arrive at answers, but also grow in their ability to evaluate, connect, and improve their mathematical thinking. Connecting is a key part of the mathematical process because it is about making links between different strands of mathematics, and links between mathematics and the real world. Without these connections, mathematics can feel like isolated topics. With them, mathematics becomes a powerful, coherent system of ideas. There are two main types of connections. The first is within mathematics. Here, students link concepts, procedures, and skills across topics. For example, algebra connects to geometry, and both can link to statistics. By making these connections, learners see how one idea strengthens another, and how mathematics operates as an integrated subject rather than separate parts. The second type of connection is beyond mathematics. This involves applying classroom mathematics to real-life contexts and to other STEM subjects. For instance, mathematics supports science through measurement and data, engineering through design calculations, and technology through algorithms and coding. These connections show students the value of mathematics in everyday life and in solving real-world problems. In short, connecting ensures that mathematics is meaningful. It allows students to transfer their learning from one area to another and from the classroom into the wider world. This not only deepens their understanding, but also helps them see the relevance and importance of mathematics in their daily lives and future careers. There are two main types of connections. The first is within mathematics. Here, students link concepts, procedures, and skills across topics. For example, algebra connects to geometry, and both can link to statistics. By making these connections, learners see how one idea strengthens another, and how mathematics operates as an integrated subject rather than separate parts. The second type of connection is beyond mathematics. This involves applying classroom mathematics to real-life contexts and to other STEM subjects. For instance, mathematics supports science through measurement and data, engineering through design calculations, and technology through algorithms and coding. These connections show students the value of mathematics in everyday life and in solving real-world problems. In short, connecting ensures that mathematics is meaningful. It allows students to transfer their learning from one area to another and from the classroom into the wider world. This not only deepens their understanding, but also helps them see the relevance and importance of mathematics in their daily lives and future careers. Communicating is a vital part of the mathematical process because it is how ideas are expressed, shared, and clarified. Communication in mathematics can take many forms: oral explanations, written work, visual representations, or even gestures. But it is not only about speaking or showing. It is equally about actively and respectfully listening to others. This two-way process ensures that mathematical ideas are both expressed clearly and understood correctly. Students communicate with different audiences: their teacher, peers in small groups, the whole class, and even beyond the classroom, with families or the wider community. Each of these contexts requires different levels of clarity and detail, but all help students practice the skill of making their mathematical thinking visible. An important feature of mathematical communication is the use of correct language, symbols, and models. When students use mathematical vocabulary precisely, when they represent ideas with diagrams, graphs, or equations, they are not just showing their answers, they are showing their reasoning. In short, communicating ensures that mathematics is not kept hidden in the mind of the learner. Instead, it becomes a shared process where ideas can be discussed, challenged, and refined. Through communication, mathematics becomes collaborative, meaningful, and accessible. Teachers play a central role in developing students' ability to communicate mathematically. Our responsibility is to create opportunities where learners can share and clarify their ideas, rather than keeping their thinking private. This allows them to practice expressing reasoning and also to learn from the perspectives of others. We also guide students to create and defend arguments, which builds critical thinking and logical reasoning. At the same time, teachers model how to give and receive descriptive feedback so that communication becomes constructive and focused on improvement. A good classroom for mathematical communication is one where questioning is encouraged. Students should feel comfortable posing questions, responding to others, and elaborating on their ideas. To make this possible, teachers must establish a safe and respectful classroom culture. Finally, it is essential to make every student feel valued. When students see that their contributions matter, whether they are speaking, questioning, reacting, or building on another idea, they become more confident and engaged. This culture of respect ensures that mathematical communication is not just about delivering answers, but about building a supportive community of learners. Representing is the process of expressing mathematical ideas, relationships, or real-world situations in different forms. These representations can include numbers, symbols, diagrams, graphs, tables, models, or even words. By using multiple forms, students are able to both model their thinking and communicate it clearly to others. Students often use tools such as pictures, diagrams, and graphs to make their ideas visible, while teachers have the important role of valuing and affirming these varied representations. Every student may begin with different experiences, and by recognizing these, we validate their learning journey. Reflection is also essential here. It helps students assess whether their chosen representation is appropriate for the problem they are solving. At the same time, making connections among multiple representations deepens understanding because it shows the same idea in different ways, reinforcing its meaning. Representing also directly supports problem solving, mathematical modeling, and communication. When learners can switch between symbols, visuals, and words, they become more flexible and confident thinkers. In short, representing ensures that mathematical ideas are not only solved, but also shown, shared, and understood. We've now explored the core of mathematical skills and processes, from problem solving to reasoning, reflecting, connecting, communicating, and representing. In the next part of our journey, we'll be moving on to look at the other key areas of STEM education. The upcoming video slots will focus on science skills, technology skills, and engineering skills. Each of these will show us how they connect with mathematics and how together they form the full picture of STEM learning.